Welcome everyone to EA Global Summit 2022. This is Sujat from EA Global Summit organizing team. It's our privilege to have Jan Dale live day in our presence. Jan works mostly involves model-based system engineering and technical management at various stages of life cycle of big infrastructure systems such as tunnels, water surge barriers, and metros. Presenting Sigma, a system engineering workbench. And I also thank everyone for your interest in joining this session. For your kind information that we will be muting all the participants throughout the session. So please use the chat window to drop your questions to the speakers. Your queries will be answered at the end of the session. We request everyone to visit the allotted Microsoft Teams channel to communicate with Jan and the other EA practitioners after the session. Jan and the other speakers accepted to stay in the channel to have a one-on-one discussion and answer all your queries. The link to the MS Teams channel will be posted in the chat window for your quick reference. If you have any difficulties in connecting to Teams, please let us know through the chat window or write.
Okay, welcome everybody. I hope you can see my screen, my presentation.
At registrations at EA Global Summit or report to EA Global Summit 2022. Without any further ado, I'll request John to session.
All right. I hope everybody can see the presentation. Welcome everybody, and thank you for attending this presentation about Sigma, a model-based system engineering workbench for the infrastructure and industrial domain. My name is Jan Liefde. I'm working as a senior system engineer in the industry domain. I strongly believe that a model-based approach help us to work together from a single source of truth and will minimize the risk on schedule and budget difference during the system life cycle. The presentation I like to present three topics. First of all, an introduction and motivation, why we have developed the workbench itself. After that, I will give you some insights in the development of Sigma. And at the end, I give you also some examples where you can see the structure and how it looks like. First of all, infrastructure systems. These are the systems you see everywhere where you live. You see the movable water barriers, the metro systems, the locks, tunnels, bridges, movable bridges, but also dikes and these kind of large systems that protect ourselves or give us some convenience in living in the country where we are. First of all, I'd like to give you some context for the Infrasystems. Infrasystems have always a high political and public interest. It's always in the spotlight. If the movable water barrier is not working, we have a security, a safety problem in the Netherlands by flooding the lower lands. We have to deal with long life cycles of the system, 80 years, more than that. But not only the long life cycle of the system itself, but also the shorter life cycle of system parts of it. We have to deal within the workbench with different engineering domains, civil, mechanical, electrical, industrial automation, environmental people, project management, or contract management. Another thing that we have to deal with is the direct or indirect impact on the environment. Night views where you live somewhere in the country, pollution, fine dust, and these kind of things. And we have also to deal with impact from the environment, salt water, winter, temperature. There's also a strong focus on safety, zero casualties, and availability 24/7. And in the projects, there are many different suppliers involved. Now, today's practice, we work in silos. That's the normal way of working within these kind of projects. They all make the design the documents or project management documents, but still in silos. And the result is then that we have created a black hole and we put all the documents in, and we don't. It's very difficult to find the right information within the black hole. What are the issues we see today? Information duplications. Looking at the projects at the moment, thousands of documents are created. So we multiply documents are the same kind of information, same information. So if you change something, it's not always done in all the documents. So we have information lost during these changes. It's difficult to get access to the information. Searching within documents, that's not a very nice exercise. An exchange of information from the documents is by using exports or copy paste. And at the end, we have a lack of traceability. It's also that there are many different data sources are used for calculations, the documents itself, databases with configuration data, and these data sources are not connected to each other. So when we like to have the intention to change something in the system, and we have a lack of insights of the impact of it, and it's still discipline based. So what we try to achieve, that's we're going from the document centric to the model centric. So by the model centric, documents still exist, but the source of these documents is in the model. So information is only stored once, not many times. So we have no more duplication of information, or less duplication of information than today practice. So model-based system engineering is also exercised in today's projects, but we see some kind of issues over there. It's mostly high-level design, so we still have focus on producing documents and not on producing a model that solves the problem. And it's focused mainly on defining functions. Objects are not are only partly modeled, so we don't have any constraints, properties, requirements is not right stored. So we still have a lack of traceability. Another topic what we see is that there are no distinction between the problem and the solution domain. Problems are used as a solution, or solutions are used as a problem. So we have to divide that. And language, especially things like SysML, UML, these kind of things are not always readable for domain engineers. So the big question is, can we create a workbench where people in the engineering and asset management domain of Infrasystems can collaborate? And what do we mean by engineering and asset domain? All the different domain experts have to collaborate. That will be the challenge. So if you look at the system lifecycle, then we see a very short period of time in the design and implementation of the project. That's what we call the greenfield project, and mostly 5 years, something like that. And we have a very long operational time, 80 years, 100 years. And if we look at the asset management, they are only involved halfway, if we have lucky, halfway in the design and implementation phase. Maintenance is involved a little bit later. But both of these have to deal with the operational phase. They are responsible for it, that the system will deliver the capabilities. So, if you look from a model point of view, we have a project model that's used in the design and implementation phase. And we have an asset management model that's used during the whole life cycle of the system. That's what we like to achieve at the end. So the project model is just part of the asset management model. And during the operational phase, there could be many projects to change the operational system. So we have to do with from a model point of view, we have to do with a lot of these project models. So we have to support then the engineering flow. When we start, we have to define the process flow, the block flow, and the asset analysis from a point of operational users. After that, we have to deal with the basic and detailed design. And we have to define the function flow, system structure. We have to define the interfaces and manage them, information flow, but also things for the domain experts, the domain engineers, piping and instrumentation, monoline schemes for the energy guys, batch engineering from the process, industrial automation. For safety and reliability, we have to deal with failure mode and effect analysis, fault tree analysis, and for the integration guys, we have to do the cable management. Achieve that. We have to make the test preparation, test case, procedures, reports, and at the end we have to deliver and keep it actual for the system configuration. Now, it's very nice that we are doing engineering, but we have to do also with the technical management, the engineering management, workflow management. From a single source of truth, we like to work together not depending on the location. We have to have capabilities like integral review possibilities, discussions for the project. Over the projects, we have to build up a library so we can reuse elements. We have to support risk management, change management, and issue management. And from another point of view, that we have to sign information that's handed over to, for example, suppliers or regulations. We have to generate documents that you can sign. From an asset management point of view, we have to give them for a very long time asset information. What are the design decisions we have built a system for? How is the operational usage intent? What are the hazards and what are the mitigations? What are the failure modes? How can we detect them and how can we mitigate them? A fault tree for reliability, interfaces, test information, and at the end also the traceability between everything. So we have a very big challenge to build up a workbench for all these guys and all these kind of information. So I'd like to give you some insight in the development of Sigma, the workbench that we have created. I like to start. How did we manage it? We use Scrum to manage the development of the system. We built up a backlog. On the sprints, we did it 2 weeks sprint reviews with some kind of customers, and we update the status. So I hope we are always in control then, that way, and it looks like. So we have created a product that you can use. So first of all, we have to take some design approach. Therefore, we use some kind of framework that's documented in the book Demystified System Engineering, and it goes from compliance to approach. We have to deal with a goal, we have to visualize things, and we have to implement it in some kind of tool that we intend to use. All these things you will see in the next slides. So first of all, to which standards should we be compliant or partly be compliant? So for the workbench itself, we use the ISO 52, the System Engineering Architecture Description Standard. For for the process, we use the methods and tools for model-based system and software engineering. So we try to be compliant to international standards, but also to other standards that are used within other industries, such as Magic Grid or the DODA standard. So first of all, we have to look who are the users. What do we think the users are using these workbench? Okay, we have engineers, domain system engineers. We have management, not only technical but also project management, contracting, supply and acquisition, asset management, and maintenance, safety and quality. We have to deal with verification and validation. That's very important in the infrastructure systems, and information management. These are the large groups of people that we think are the intended users of the workbench itself. So we have to define the process based on 4 pillars: planning, the engineering, design, modeling for supporting the design, and support for support planning, design, and modeling. For some kind of ontology, we use the approach from the book System Engineering 3rd edition from John Holt. That gives a broad insight in ontology that we use, not for building up the system itself, the workbench, but for using it in the working field. So we build up also an ontology for the workbench. And that's very interesting because we're using standard SysML. That's a common language within the infrastructure system design at the moment. We intend to use Enterprise Architect. We look, okay, what kind of artifacts we need to work with. So we divide it in 3 groups: SysML, Enterprise Architect, and the relationships. So SysML are the green box, Enterprise Architect are the blue box, artifacts that are available within these kind of languages. And we missed some things, and these are the yellow boxes and the yellow lines, and that's what we have integrated within the workbench in different toolboxes and different diagrams. We have to look at a more precise intended user side, and we have look at all the different groups that I've mentioned before. So from the management group of people who are intended to use it: project managers, risk managers, configuration, environmental manager. We have to deal with the verification and validation users, VNV manager, test managers, but also the test engineers, for example. Information management. These are a more precise look at the different uses of the workbench itself. So we build up some viewpoints related to these users, and we give them some kind of relationship between the different viewpoints, and that will be the start of the structure of the framework itself. Will it be integrated in the workbench? So another point that you have to look what kind of systems will or can be modeled with the workbench. As I mentioned, the infrastructure are like movable bridges, locks, movable water barriers, tunnels, metro systems. That's are the intended systems that we like to model. So when we have defined the viewpoints itself, we have to also define the views from the different perspectives of the users. So we make for every user the different views with a small description and a relationship to the structure itself that you look in some other sheets further on in the presentation. Okay, what kind of models are users interested? Okay, as I mentioned before, we have two kinds of projects, greenfield and brownfield projects. And what we see in practice that there's only interested in user only interested in descriptive models from top-down approach. How will we look the system in the future? Analysis models. Okay, let's think about failure modes, hazard analysis, all these kind of things. Interfaces, complexity of interfaces. That's we use. For the brownfield projects, we have to make a descriptive model of the each situation and the sole situation, the situation you like to reach after the design and build. And the analysis models are then pointed at the delta between the each and the sole situation. And that will be the definition of the change of the system in the brownfield projects, for the brownfield projects. Users are used to live with different visualizations or different notations. So we have to give them some graphical information in a graphical way, reports, charts, and matrices. That's what they use at the moment. What they normally do that in Visio and in Excel. These kind of tools they use for these kind of visualizations. So at the end, we have to define all the different kind of diagrams that we use to do these visualizations that we seen before. We have some generic diagrams from SysML, like the requirement or activity diagrams or the state diagrams, and we have to add some new domain-specific diagrams for project and technical management organization diagrams. For the safety engineers, we have to, the safety manager, we have to define the hazard, failure mode and effect, and the fault to analyze diagrams. For the mechanical engineers and the instrumentation engineers, we have to build the PNID diagrams, the A1 line schemes for the electrical engineers. For the V&V, verification, validation, and testing group, we have testing diagrams and testing toolboxes. For the configuration manager and the integration managers, we have built the implementation diagrams. For the batch industry, we have to do based on the standard, ISO standard, physical recipe and process diagrams. And for the automation engineers, we have to build function block diagrams. That all these diagrams are needed to make an integrated design of a system from the different domain perspectives. So, and what are the tools then that we use? Enterprise Architect, Pro Cloud Serve and Collaborate. The choice is there because the Enterprise Architect is widely used within the Netherlands. By a lot of companies are doing also the design at the moment. So at the end we have make some kind of overview of the whole Sigma workbench. And what we have integrated within that, we have design standard, the design processes, design method, modeling guideline. For the management, we have integrated issues, changes, risks, schedule, design issues and deviations. We have built up our library with domain-specific languages, reusable model elements, and document templates based on a framework from 6 different models that can be used with all together, but also module-wise for everything. And we built it in the application Enterprise Architect, Pro Cloud Serve and Collaborate. So in the next slides, I will give you some overviews of examples of Sigma. So to give you some nice views of it and how it can be used. So for the process, we have defined different processes. We build it up in BPMN with different descriptions. So and different abstraction level of the process itself. So for support for quality management, configuration management, and information management, we have to do the processes for the design engineer, system architect, domain experts. We have set up processes with descriptions, how they can use it. And for the modeling, for supporting the design process, we also define the different roles who are intended to do these kind of processes and activities within it. All the different products they have to deliver, also integrated within the process model. We have to define a method so that people can use for doing these kind of projects. So in the vertical slides, you see from an operational view to the implementation. That's the configuration that's really outside in the field. And on the horizontal line, you see requirements, functions, structure, verification, validation, analyzing, and simulation, and also how these different artifacts are related to each other. We set up a working guideline, so it's nice that you have a process, but we have to give them some more hands-on experience how they can use the different models when they're doing the engineering part. So it's all built from the same structure. So we have a generic description of the working guideline, what kind of diagrams, toolboxes are used. Per activity, we have a description, and the different relationships are used within the working guideline. We have set up a modeling guideline, so it's nice that people can see how they have to model it and what kind of artifacts they're using to model these systems itself. After that, we have set up a model validation guideline. So different checkboxes that you can use to validate your model if it's built in the right way. Not if the design itself is very good. That's will be done in the reviews from a verification point of view. But is the model built up in the right way according to the model guidelines and working instructions. So after that, we have set up a framework from the different models, operational model, where we can define all the from the user's point of view, a functional model where we can do all the analysis, value modes, for example, and we can set up a system architecture structure, define the different functions for the different system elements, different state, every block has a state machine, and the interaction between all the system elements and the external system that we have to deal with. In the technology model, you can model all the technology variants that you can use to realize the elements that you have defined in the system structure at the functional level. And we have an implementation model where we do the configuration was really outside. So that's what we see in the projects, the configuration management database. And we have a library for reuse of elements and patterns and these kind of things that you can reuse within the project or over the projects. So, as I mentioned before, we have defined additional diagrams. You see a list of it, and every diagram has its own toolbox. So every domain-specific diagram has also a domain-specific toolbox. And we set up a common, as what you see also in Enterprise Architect, a common toolbox with different model elements and different relationships that we can that's what we miss within the today version of Enterprise Architect. So you see some examples of the different domain diagrams that we use. Piping and instrumentation, industrial automation, function blocks, fault tree analysis, failure modes, and for the energy to online schemes. And for every element that we have defined, that we have in ticket values, the asset information that you can fill in. So you see in the structure of the operational model, what are the actors of the system, analyzes the hazards, capabilities, in operational interaction within sequence diagrams, scenarios, operational states, reference, stakeholder requirements, and user goals that you have to reach. You see the operational capabilities and system, an example of it. In the functional model, we build up the functional flow of the system. What are the functions and the functional breakdown? That's an hierarchical breakdown of all the functions that we have defined. In the analysis, you see, for example, a value mode and effect analysis. The architecture of the system itself, the properties. In the technology model, what are the technological solutions that we have that you can bring in related to the functional model? You see some slides of it from a technical point of view. And you see left the functional breakdown and the internal block diagrams, for example, for it. We have an implementation model That's what we miss in most of the frameworks that's been used. Implementation model is what's really outside of what will be intended to be outside. So you see the cabinets, configuration of all the equipment, data networks, energy distribution, cables and piping, piping instrumentation, all the interfaces and all the different testing. So we only use some new relationships over there. We have a configure because you can, if you're building up a system, you don't build it in a big bang. You build it in different configurations. So every configuration can be then related to a certain point of time. We can say some kind of automation functionality, for example, will be hosted by some automation system, but it can also be hosted in the object itself, the equipment itself. For example, the power supply of a pump can be implemented somewhere, and you have to give where your equipment is installed, and that's where we use the locate relationship. You see an example of a real project that we are building up a pumping station within the region. That's the blue ball that you see in the geographical picture, all the pumping stations over there. And what the sewage treatment plant, you see the high level structure and the different designs of it. For piping and instrumentation, we have set up a structure for it, and we use there the reference to different cable types, fire class types. You can relate it to the different cabinets. We did not build it with the normal relationships because this is very easy to fill in for the integration guys. We have to give the technical management and project management a management model. So you can use, for example, Scrum, all the different roles they use, but also the work breakdown package if you like to use it. All the changes, phasing, deviations, all the kind of things you can fill in within the project related to other things. So we set up also new relationships for the organization so that you can build up a ROSCI table for the products and the work packages. You see an example of it. We set up a library with for different products. So for every kind of system, the energy, CCTV, intercom, automation, fire, this thing is. We set up all the different kind of products that you have to deliver in the different phases of engineering. We set up basic design reports. So for the design documents, a stakeholder requirement specification or system element description that we can reuse over the projects. We set up a set of reusable units, quantity guides and constraints that we can reuse within in the different projects. And we use collaborate for the non-enterprise hosted users. We deliver them not only basic collaborate functionality like reviews and discussions, but also give them a special dashboards. This is an example of a dashboard that we have done built for a project from a management point of view, where you can see your schedule and progress, all the different changes made in, from a customer, project risk, and the project deviations. So at the end, we build up A workbench we can work together from one single source of truth. You see an example from the office. What we already, we have next steps. We have to update the working guideline. It's not finished at the moment. From new insights from projects that we're using, the modeling guidelines we have to update, profiles with new insights. Maybe we have to change, or maybe we have to extend with new. And we have to extend the library with common standards, reusable elements, requirements that we can use within different projects, and reusable constraint blocks with all the calculations. And hopefully do some kind of simulation. But what we see is the market is not really ready for it to do with that at the end. Okay, this was a presentation, a short insight of what's the market where we work in, how did it develop the workbench itself, Sigma, and how we use it within the different projects. So if you have any questions,
I thank Jan for, on behalf of everyone, for making this session a wonderful one. As we said earlier, now it's time for question and answer, and I will be reading out the questions from the chat window, and Jan will be answering them. A question from Johan. Okay. How do you create and manage electrical drawings like circuit diagrams?
Okay, we make a profile for the PNIDs, and we use ShapeScript for these kind of things.
Okay, thank you. The question also posted in your dedicated Teams channel. You can also answer there. And another question from Johan. Many good ideas. Can you describe what you have used in some real project?
Yeah, we use parts of it in previous projects, and what we have done, all the things that we have done within projects, we have combined it into a single workbench. That's what we have achieved. So it's based on today's practice.
Okay. You also requested, can we download the slides? It would be easier to read the finer details.
Yeah, I will put it after the presentation. I will place it in the Teams environment.
Okay, thank you. And how do you structure and tag and name data? Are you using ISO 81346 with parts 1, 2, 10, and 12?
Yeah, this is also a very nice question. There's a discussion within the infrastructure domain about tag data. That's and when it's finished, I will integrate it in the environment as a tag name. It's also available as a single tag name, but you are not you don't have to use it according to the ISO standard. You can use it in that way, but you don't have to. But we can integrate it.
Thank you, Jan. We'll wait a couple of minutes for questions, and we'll move to the Teams channel.
Yes, okay. Thank you. Thank everybody for attending the presentation.
Okay. Thanks, Jan. And thanks to everyone for your time and support throughout the session. Hope it's very informative and gives deeper insight into the topic. Now, Jan will be available in MS Teams to have a detailed discussion and answer more questions. The link to the MS Teams channel is posted in the chat window for your quick reference. If anyone is having any difficulties in connecting to Teams, please reach us at the chat window or write us at registrations@eaglobalsummit.com. Thanks once again, everyone, and looking forward to host you all in another wonderful session. Thanks, Jan.
Thank you. Thank you, everybody. Bye.
Bye. Thank you.